Korea, 1951. A soldier wakes up in a trench with a fever. He will be dead in 4 days. His doctors have no idea why. And here's the question, 40 years later, in a completely different country, in times of peace, in the middle of the desert, a perfectly healthy marathon runner will wake up with the same fever. He will be dead in 48 hours. Same killer, different continent, different decade. No connection between these two people. So what was hunting the two of them? It wasn't another soldier. It wasn't a terrorist. It wasn't a weapon built in a laboratory. It was a rat. A small, ordinary mouse 12 centimeters long, with a brown stripe on its back that had lived peacefully in the river valleys for thousands of years, carrying something inside it, something it didn't even know it had. And we, humans, entered their territory. We dug our trenches in their dwelling. We slept in their bunkers. We breathed their air. What happened next killed thousands of soldiers, puzzled military doctors for 25 years, crossed an ocean unnoticed, and even today at this very moment has no cure. This is the story of the Hantavirus, and it all doesn't start with science. It doesn't start in a laboratory. It begins with a war that turns the world upside down. To understand what happened in Korea, it is necessary to understand what war does to territory. Not for the people, for the land itself. When armies invade a rural landscape, rice paddies, river valleys, forested hills, they don't just occupy it. They devastate it. They dig miles of trenches, meters deep, churning up land untouched for generations. Land that harbors an entire ecosystem, roots, insects, fungi, and animals. Small animals, the kind that nobody notices. The interior of Korea was home to Oppidamus agrarius, the striped field mouse. Small, brown, completely forgettable. These mice had lived in the valleys of Korean rivers for thousands of years. They had their territory, their food sources, their nests in the ground, and they carried something within them, a virus that had probably accompanied their species for as long as they had. The virus didn't make them sick. It was part of them, a passenger, harmless to the host. But then humans arrived, and humans brought food. Imagine what a military camp would look like from a rat's point of view. Suddenly, its territory is teeming with noisy creatures carrying enormous quantities of grain, canned goods, and bread. They dig deep burrows and sleep in them right at the rat's height. They leave debris everywhere. Essentially, they create the perfect habitat for rats. Thousands of rats swarmed the trenches, the soldiers, exhausted and focused on avoiding being hit by bullets, barely noticed. That was the mistake. But here's what nobody has understood yet, and what makes this story far more disturbing than a simple problem with rats. The danger did not come from the bites. The soldiers weren't being bitten. The rat wasn't attacking anyone. It was simply about living there, urinating. Constantly, rats mark their territory with urine, leaving microscopic traces. Wherever they go, on the grain bags, on the floor, on the bunker walls, on every surface they touch, and then that material dried. When organic matter dries in an enclosed space, it turns to dust. And when you move through that space, when you sweep, organize materials, simply walk and move the floor, that dust becomes suspended in the air, and you breathe it in. There's no point of contact you can point to, no wounds, no obvious exposure, just air. The same air you've been breathing for weeks, air that smells of damp earth and canvas, and the peculiar misery of a Korean winter trench. Every breath inside those bunkers was a gamble. Most men didn't inhale anything, or they inhaled particles, and their immune systems dealt with it silently, without them even realizing it. But some men, and nobody fully understands why some, and not others, even today had their immune systems reacting to the virus in the most catastrophic way possible. Not exactly the virus itself. To your own immune response to the virus. The body detected the infection and went to war against itself. And here's the cruelest irony of this whole story. The healthier the immune system, the more intensely it fought, and, in some cases, the faster it killed. Young soldiers in excellent physical condition died faster than older, less fit men. This was because their bodies fought so aggressively that the inflammation itself became the weapon. The fluid flooded places where it shouldn't have been. Blood vessels began to leak. The kidneys, overwhelmed by the systemic chaos, began to fail. Doctors called it Korean hemorrhagic fever. The men in the trenches had other names for it, none of them publishable. More than 3,000 United Nations soldiers were killed during the Korean War. Hundreds died. And the worst part, the part that truly terrified the commanders, was that there was no pattern, no logic. You couldn't avoid the attacks by staying clean, eating properly, or going unnoticed. All it took was having people ... and nobody, not a single doctor, not a single military scientist, knew what it was. But something even more frightening than the disease itself began to circulate. A theory, a suspicion so dark that it led military intelligence to get involved. The field hospitals near the Imjin River in 1951 were not prepared for this. Nobody was. Imagine being a military doctor in Korea. Soldiers arrive every day with gunshot wounds, shrapnel, frostbite, dysentery. You have a system for those. Brutal, exhausting, but a system. You know what to do. And then these men begin to arrive, young, strong, without visible injuries, just with a fever. You give them aspirin, you give them fluids, and you observe. Third day, bleeding begins. Bruises appear out of nowhere, spreading across the abdomen and back. The eyes turn red, the urine darkens. The patient who complained of a headache for 48 hours is now experiencing multiple organ failure. And you're just standing there with nothing to offer. No antiviral, no specific treatment, no explanation. Just a young man with the chest of a runner and the arms of a soldier dying before you, while you deal with symptoms that don't respond to anything you have available. The suspicion began discreetly, whispered among the police officers. It later turned into a formal investigation. What if that's not natural? This was the Korean War. The Cold War was in full swing. Both sides had biological weapons programs or were suspected of having them. And then a sudden disease emerges, striking men of combat age without a defined pattern, leaving no trace detectable by conventional diagnostic tests, and killing with ruthless efficiency. Some accounts from this period indicate that the possibility of an enemy biological attack was taken seriously enough to involve military intelligence units, not as paranoia, but as a genuine operational concern. They were wrong. It wasn't a weapon, but the fact that experienced military scientists, analyzing the full picture, actually considered biological warfare a more plausible explanation than a natural pathogen that speaks volumes about how strange, sudden, and devastating this event was. The answer wasn't in a laboratory. It wasn't in an enemy weapons program. It was in the countryside, literally in the rice paddies and river valleys of rural Korea. And it would take a man, a very stubborn man, very tormented by grief, 25 years to find it. His name was Ho-Wang Lee, South Korean virologist, calm, methodical, the kind of scientist who doesn't make the news because he's too busy doing the real work. After the armistice of 1953, the war ended, the trenches were abandoned, the armies retreated, the world moved on. The disease doesn't. The cases kept coming, no longer in the hundreds, but steadily. Korean farmers, soldiers near the demilitarized zone, farm workers, every year, the same pattern, the same devastation, the same lack of answers. For Ho-Wang Lee, this was not an abstract scientific problem. He had lost his brother to this disease. This specific pain, the kind that doesn't fit neatly into professional distance, the kind that stays with you in the middle of the night, became the driving force behind an obsession that would consume the next quarter century of his life. He began systematically capturing and testing rodents throughout rural Korea. Thousands of animals, thousands of blood samples, year after year, throughout the 1960s and into the 1970s. His colleagues thought he was, if not exactly crazy, at least overly obsessed. Capturing field mice isn't the kind of work that earns international conferences. There are no glamorous moments in analyzing blood sample after blood sample from animals that most people consider pests. But Lee continued. He tested urban rats, the common brown rat, the species that lives in every city on the planet. Negative. He tested other species. Negative. He followed the epidemiological trail. Where were the cases concentrating? Near rivers, near rice paddies, near farmland, near Epidemus agrarius, the striped field mouse. 1976, 23 years after the end of the Korean War, Lee captures a striped field mouse near the banks of the Hantan River, 60 kilometers north of Seoul, in the shadow of the demilitarized zone, in the same type of river valley where soldiers died. 20 years earlier, he examines his blood. Antibodies, unmistakable. This mouse is infected with the virus, exactly that species, exactly that region. Lee had found it, the reservoir, the animal that had silently carried this pathogen for probably thousands of years, living in river valleys, occasionally infecting a farmer who got too close, largely coexisting with humanity at a distance that kept everyone safe. Then came the war, and the armies entered the scene, and the distance disappeared. He named the virus after the river where he found it, Rio Hantan. Hantavirus, a name that immortalized the place where a 25-year-old question finally got an answer. After Lee published his findings in 1978, scientists did what they always do when a new piece of the puzzle emerges. They started searching everywhere. If there is a hantavirus in Korea, could there be others? They existed, many others. Researchers have identified related viruses in Europe, Asia, and South America. The Pumala virus in Scandinavia, transmitted by the field mouse, the Dubrava virus in the Balkans, the Seoul virus transmitted by common brown rats, meaning it spread globally along trade routes, likely for centuries, hidden in plain sight on ships, docks, and grain silos around the world. Each continent with rodents had its own hantavirus, each shaped by millions of years of coevolution with its specific host, each with its own level of danger, all with the same basic pattern: hemorrhagic fever, organ damage, exaggerated immune system reaction. None of them have a cure, and then, just when the scientific community thought it had solved the mystery, the virus brought one last surprise, and he delivered the product in a dessert. May 1993. The Four Corners region of the American Southwest, the meeting point of New Mexico, Arizona, Colorado, and Utah, land of canyons, red rocks, silence, and an immense sky. Nothing in this landscape suggests an outbreak of infectious disease. A young Navajo man, a marathon runner in excellent physical condition, collapses with respiratory failure. He dies. A few days later, his fiancée, also young and healthy, also dies. Researchers find more cases. Young adults, no obvious connection. Quick and brutal death, but this time it wasn't kidney failure. Lungs. The lungs filled with fluid so quickly that the patients drowned from the inside out. The Centers for Disease Control and Prevention sent a team. The Indian Health Service was already on site, and within a few weeks, they identified the culprit, a previously unknown hantavirus transmitted by the field mouse, Promyscus maniculatus, a small, wide-eyed rodent native to North America. The deer rat is everywhere in the American West, in garages, in cabins, in woodpiles, in the spaces between walls. The year 1993 had been atypical. An El Niño climate phenomenon had flooded the desert Southwest, producing an explosion of food sources: pine nuts, insects, seeds. The population of field mice had quadrupled. Mice that normally roamed vast territories now clustered densely in the same spaces as humans. The new virus was named Nombre, which in Spanish means without a name. That makes sense, because it had been killing people silently, undetected, in North America, possibly for centuries. Oral histories of Native Americans, researchers later suggested, may contain references to disease outbreaks entirely consistent with this pattern. The virus wasn't new, only the knowledge about it was. The Nombre strain caused what we now call Hantavirus pulmonary syndrome. Unlike the Korean version, it primarily targeted the lungs instead of the kidneys. But the underlying horror remained the same exaggerated immune response, the same fluid, buildup where it shouldn't be. and a mortality rate in those first outbreaks of about 40%. Once the severe symptoms began, her chances of survival were practically 1 in 50 or a coin toss. There was a nurse in New Mexico in the summer of 1993, not famous, not in the history books, who later described working those early cases. She said the speed of deterioration was unlike anything she had trained for. A patient who walked into the clinic complaining of muscle pain and shortness of breath was on a ventilator within hours. By the next morning, he was gone. That speed is everything. That is what makes hantavirus pulmonary syndrome so specifically terrifying. From the first to the fourth day, the symptoms are exactly the same as the flu, fever, intense muscle aches, mainly in the thighs and back. Headache. Fatigue, maybe a little nausea. Nothing that indicates an immediate trip to the hospital. Nothing that differentiates it from a dozen other illnesses. You feel unwell, you rest, you wait for it to pass. It won't pass. From the fourth to the sixth day, the worsening. Doctors call this the cardiopulmonary phase. Patients describe feeling fine in the morning and struggling to breathe by afternoon. The blood vessels in the lungs become permeable, they leak. Plasma floods the lung tissue. The lungs, now waterlogged, can no longer exchange oxygen. Breathing becomes labored, then agonizing, then impossible without a machine. The heart, overwhelmed by the crisis and directly damaged by the virus, can go into. This phase lasts from 2 to 5 days, and it is this phase depending entirely on the proximity of a hospital with intensive care capacity that may or may not lead to death. Those who don't survive usually die within the first 48 hours. To fast. To severe. The body destroys itself before any intervention can stop it, and those who survive, most recover completely, which in itself is a miracle given the violence of what just happened inside them. The treatment, both then and now, is this: keep the patient alive long enough for their own immune system to win. Mechanical ventilation, sometimes ECMO, a procedure where blood is taken from the body, oxygenated mechanically, and returned, essentially doing the lungs' job while they recover. Careful fluid management, cardiac support, and waiting. That is the complete treatment plan for a disease first documented over 70 years ago. No antiviral proven to cure it. No widely available vaccine in the Western Hemisphere. You get infected, reach a hospital fast enough, and survive on the margin between what modern intensive care can hold together and what the virus can take apart. And the only real prevention, the only weapon humanity possesses that truly works, is the same one the soldiers should have used in those Korean trenches in 1951. Don't let the mouse in. Hantavirus is not a disease of the cities. It's a disease of the suburbs, places where human life meets the habitat of wild rodents. Cabins closed all winter, opened in spring dust, and rat droppings stirred into the air as the places aired out for the first time in months. Barns, piles of firewood, old vehicles abandoned in fields, campsites in areas with high rat populations, agricultural work on the edges of wilderness areas. The CDC has documented approximately 700 confirmed cases of hantavirus pulmonary syndrome in the United States since 1993. 700 in 30 years seems manageable, until you remember that 36% of those people died. And these are confirmed cases. Hantavirus resembles many other diseases in its early stages. How many deaths in rural areas attributed to respiratory failure of unknown cause in the decades prior to 1993 were actually caused by this virus? Honestly, we don't know. The situation in South America is even worse. Brazil, Argentina, Chile, Paraguay. The diversity of rodents in South America results in an explosion of hantavirus variants, some significantly more lethal than North American strains. And then there's the Andean Hantavirus, found in Chile and Argentina, which possesses a property that no other known hantavirus on Earth shares. It can be transmitted from person to person. 2 documented patients who had never been near a rat developed hantavirus after close contact with an infected person. This is a biological exception that does not exist in any other member of the hantavirus family. And it is the kind of exception that keeps virologists concerned, even if discreetly. From a professional standpoint, in Asia, the hemorrhagic variant, the original Ho-Wang Lee strain, still infects between 100,000 and 200,000 people per year, primarily in China, mainly rural agricultural workers. In most cases, the disease is treatable if treatment is started in time. But 100,000 people a year, every year, silently, with a disease that most of the Western world has never heard of and cannot name. The world has a very short attention span for diseases that kill silently. This is the part of the story I always come back to. The Korean War outbreak was not random. It wasn't bad luck. In retrospect, with all that we know now, it was completely predictable, because it follows a pattern. One of the most consistent and most ignored patterns in the entire history of infectious diseases. Imagine a landscape in balance, animals, plants, microbes balanced with each other for thousands of years. Then, you introduce a massive disturbance, a war, deforestation, agricultural expansion into new territories, a single exceptionally rainy year that causes a rodent population explosion, and the balance is broken. Disruption creates contact. Contact creates disease. HIV emerged from the disruption of Central African ecosystems. Ebola rises at the edges of deforestation. Nipah from pig farming pressing into fruit bat territory. SARS from wildlife markets under stress. Always the same structure. Wild animal, ancient virus, harmless in its host. Human expansion. Closes the distance. Contact. Spillover. Outbreak. Hantavirus makes this undeniable. You can draw a direct line from the trenches dug in the Hantan River Valley to 3,006 soldiers. The mouse was there first, and we are still doing this. The next outbreak is not a question of if, it's a question of which edge, which animal, which ancient passenger, and whether we find it before it finds us. Research on hantavirus has progressed, slowly, but forward. Scientists now understand the viral mechanism far better. Hantaviruses are negative sense RNA viruses, carrying genetic information in a form that must be transcribed before it can be used, making them harder to target with antivirals. Ribavirin showed some promise for Asian kidney-targeting strains when given early. Monoclonal antibody therapies are in development. ECMO technology, which barely existed in the 1990s, has dramatically improved outcomes for the most severe pulmonary cases. A DNA-based vaccine candidate for Nombre completed Phase 1 trials with promising results. It has not received final approval. Funding is scarce in South Korea and China. Inactivated virus vaccines exist for high-risk populations. Their effectiveness is debated, but they exist. The most effective prevention remains, as always, keeping mice out, seal gaps in buildings, ventilate enclosed spaces before entering after long disuse, use respiratory protection when cleaning areas with rodent activity, wet clean rather than sweep, humble, unglamorous, extraordinarily effective. The Hantan River still flows through South Korea, through Seoul now. 10 million people, bridges, apartment towers, weekend parks. The valley where Ho-Wang Lee found his mouse is still there. In the shadow of the demilitarized zone, the striped field mouse is still there too, still carrying its ancient passenger. In the Four Corners, the deer mouse is still there. Every few years, another case. Another person who opened the wrong cabin, cleaned the wrong barn. The virus doesn't advance impulsively. It doesn't plan. It doesn't need to. It has all the time in the world. Ho-Wang Lee died in 2022. He was 90 years old. The Western scientific press gave his death a paragraph, a footnote. He deserved more than that. He found the answer to a question that killed thousands of soldiers. He named a virus that had terrorized a peninsula for decades. He built the surveillance networks and trained the researchers that connected every subsequent hantavirus discovery across Europe, the Americas, and Asia into a single coherent map. And he did it with mousetraps, with blood samples run in a modest Korean laboratory. Over 25 years, without giving up, because his brother died from something nobody had a name for, and he decided that was unacceptable. That stubbornness is one of the quiet heroisms of 20th century science. Not celebrated, not famous, just necessary. A soldier breathing dust in a Korean trench. A marathon runner collapsing in a New Mexico canyon. A virologist setting mousetraps in a river valley, decade after decade. A mouse running through tall grass, carrying something it doesn't know it has all connected. By a thread of biology running through all of human history, this unresolved negotiation between our expansion and the world we are expanding into. Somewhere right now, a scientist is trapping rodents in a landscape nobody is watching, looking for the next hantavirus, the next unknown passenger. Let's hope they find it before it finds us. If you made it this far, you already know what to do. Share this with someone who needs to hear it. See you in the next one.